So I want to talk today about message brokers and why using message brokers, and we will take here RabbitMQ as an example, is very effective way for your backend scalability and for concurrency handling as well. So what will happen normally, like if the client makes a request, it will only get received by one backend server, and the backend logic will be processed by this only one backend server. But using message queues and with RabbitMQ, what we can do is that this one backend server that will receive this request will actually share this request to many other backend servers that shares as well the same queue subscription. So imagine if you have one server here and all the requests keep coming to this server here. So all the requests keep coming to the server. So let's say the maximum amount of requests that this server can handle 100 requests per second. So after 100 requests, this backend server will be throttled. So what we can do instead using queues is that every request that will be sent to utilize a particular API or process, this process will be shared not all on one server, but instead it will be shared with multiple servers here. Be shared with many servers, not one server. So instead, what will happen here is that this request from the client is going to be shared between all these backend instances, which will help with concurrency for our application. Okay, so looking at our application, if you are using like backend system, any backend framework like Node.js, NestJS, okay, so we're going to use RabbitMQ. So what is the addition difference a powerful message broker like RabbitMQ introduce or provides us? It actually provides us many abilities. One of the best features is the RPC model support. So RabbitMQ supports RPC model, and with the enhanced libraries and the integration with RabbitMQ and NestJS, it handles many work behind the scenes. So what is exactly the advantage of the RPC model here? So RPC model, so let's look at this again. So this client, okay, or many clients, whatever, keep sending requests. After I send the requests, I can no longer listen to these requests. It just got published to the RabbitMQ. Okay, so the RPC model actually makes us listen to this request. And the advantage of this is that we can reply to the client synchronously. So this is the best advantage here. Like imagine sometimes we need things to go synchronously, and some other times we need things to go asynchronously. So if we're going to like an asynchronous examples, like email notifications, like subscriptions or email notifications, okay, so these type of requests can go asynchronously. The client don't need to wait to get the email notification, for example. But in other hand, what we need to go synchronously is like the ordering requests. If I'm making a purchase order, for example, the client here needs to know whether his payment or purchase order got successful or not. So in this way, or in this case, we need to use a synchronous example. So the solution that would fit here is the RPC model. So the RPC model here, the advantage, what is the advantage? Is that when the client is sending a message, it will actually in the same time create a reply queue. So client 1 here is publishing a queue, but in the same time it will create a reply queue, and also it will listen to this reply queue. And also the server here will do what? Will publish the response, where it will publish the response will publish it to the reply queue here. So as a result, the client here will receive this response. So this is, the ultimate advantage here. Okay, so like briefly here, client 1 publishing queue name for the subscription like create PO, and here is a message or the queue, the exchange sent to the message queue, and then we have here the server who will process the request. So the server that will process the request here, okay, after processing the request, it will send the response to the reply queue, and then hence the client 1 will receive its reply and then respond to the front end. Let's look here at our application. Okay, so let's look at this application. So this is an NestJS application. Let's start step by step. So we have only here our the NestJS, the Nest app instance, and it's listening for the the HTTP port here on our port. What we need to do here is that we need to add support for microservices in our application. Okay, so we'll just simply add or install the packages for the microservices and for the RabbitMQ. Okay, so first we will install NestJS microservices, and then we'll install the RabbitMQ package. After this, we will install the type support for the MQ. So after this, I will just copy and paste the answer. You will have all the codes in the GitHub repo. I will share the link here. You will add the microservice here. The microservice here will support the message broker that you will use. Okay, so you will define here you will create a microservice and then define the transport type. So the transport will be RabbitMQ, and you have here the option for the configuration, the URL, and the queue, and the queue option, and also the queue option is going to be durable. Durable, it means that your RabbitMQ instance will survive messages even if the RabbitMQ instance restarts. Okay, so this is the point from the durable option here. Okay, so let's think about our example here. So our example here is that we are going to deploy an API for the currency conversion. We'll have a currency conversion API here, and what we will do, and it's going to be very similar to what we have in this diagram. We will have a client sending a request, and we also gonna have a subscriber here. So this server subscribes. So this is like a process, like a module or a server that has a subscription to this queue, which is the create PO, and then we have the processor that will process the request and then send the response to the reply queue here. Very similar. Okay, if we looked at our application here, so we have the conversion module. Okay, so after setting up our microservice, okay, we will have here the conversion module. So the conversion module here, it will have let's just also copy and paste it and then describe what we're doing here. Okay, so what we're doing here is that also let's remove the email service. We don't need it now. We just need the RabbitMQ service, which is the conversion API service. So we have client module. It's actually from the microservice from NestJS. Okay, so we'll have the client module here. We're gonna register our RabbitMQ service here. Okay, so we're gonna add the RabbitMQ here client. So I actually made a factory for the RabbitMQ client here for reusability. So the RabbitMQ client here, it just takes the queue name. After the queue name, it will have the config module and the config service, and we'll use the use factory. And here we'll add our transport and the queue configuration. Perfect. Okay. So here in the conversion module, we made the register async. Okay, so let's now check the conversion service here. and then we're gonna check the conversion consumer and then the conversion processor. So let's look at this. So first we're gonna start, of course, with the controller. So we have here controller. It's simply gonna, access the conversion service to request the service here. Okay. So now here we have the request conversion. So now we need to make use of our factory from the conversion module here, and we're gonna inject the Rabbit service. So we're gonna inject the RabbitMQ service, okay, and it's gonna be our, the client proxy, which is RabbitMQ. Perfect. Okay. So here, what we're doing, we'll have our Rabbit client. So here we will send the message to the queue. So now we're gonna send the message to the queue. So the queue name is conversion request here for the subscription. So this is for the subscription. Okay. Sorry, not the queue name. So this is a subscription message. So let's check what actually it does. So we have here in the conversion consumer, okay, because if you remember, we have here consumers. These consumers actually listen to these queues, okay. So this like create PO subscription. So we have here a message pattern which is conversion request. So we have here our message pattern, which is the conversion request. So then we're gonna handle the conversion, okay, and then what we're gonna do is that we will process the conversion here, okay. So we have the processor which will process the conversion. So let's look at the process conversion, okay, from the conversion process service. So now if we look at this message pattern, the magic here is that it's not only one server or one application instance that is listening to this request. Instead, it's actually all our backend applications that have this subscription is gonna listen to this publish request. Okay, so we have here our consumer is actually gonna listen to this request and then gonna process it. So the processor is actually the logic part of the request. Okay, so this is the actually normally processing the transactions and all this stuff to get the results from the database, and then we're gonna return the response here. Okay, so what is significant here is that I'm returning this response. So this response, it's actually here, if we looked, so this response is actually going to where? It's going to the client making the request in the first place. So this is a beautiful thing here. So our request here is actually got sent, and it was being listened to by multiple servers, many servers that can scale these requests, and any server who has availability can process this request and then respond to our queue. So this is the best part here. So simply after doing up our process work, we're going to return the response, and then our conversion service here will receive this result. So this is amazing. And then we're going to return the result. So this was a very brief overview of RabbitMQ with the RPC model. So I hope you got any benefit from this video, and please let me know if you need me to explain more any part of this video, and hope to see you soon. Goodbye.